For a century, the tank was the undisputed king of the battlefield, an invincible steel titan. Today, new weapons are rendering the heaviest armor obsolete. The race is on. Projectile versus protection. This is the brutal, high-stakes fight to build the shield of the future before the metal coffin becomes the standard. The history of mechanized warfare is an incessant, bloody dialectic between the projectile and the plate. For decades following the Second World War, the main battle tank, MBT, reigned supreme. Its increasing thickness of rolled homogeneous armor, RHA, offering a grim, albeit straightforward, solution to kinetic energy threats. Yet beneath this seemingly impervious shell lay a profound and growing vulnerability, exposed first by the revolutionary efficacy of the shaped charge, the high-explosive anti-tank heat round.
This was the thermodynamic assassin, capable of piercing previously inviolate thicknesses of steel, not through brute force, but through the precise, terrifying alchemy of the Monroe effect, creating a hypervelocity jet of molten metal capable of incinerating the crew within. This philosophical crisis reached its terrifying apotheosis in the crucible of the Yom Kippur War of 1973. Across the sands of Sinai and the Golan Heights, the battlefield became a gravedigger for armored supremacy.
Soviet-supplied 9M14 Malyutka, the infamous Sagar missile, guided by relatively untrained operators, proved that the era of relying solely on mass and angle was finished. Hundreds of Israeli tanks, including the mighty Centurion and Patton, were slain by these cheap, wire-guided projectiles. The message delivered by the Sagar was unequivocal. Any nation fielding armor must either adapt or accept obsolescence. The response to this existential threat ushered in the most revolutionary period of armor development since the introduction of sloped plating, the birth of the composite shield. The Western solution, pioneered in secrecy by British laboratories at Chobham, was the development of highly classified layered armor, famously dubbed Chobham armor. This was not mere steel. It was a sophisticated ceramic-based matrix interwoven with metals and elastomers, designed to defeat the shaped charge not by stopping the jet, but by shattering its integrity. As the heat jet strikes the composite matrix, the ceramic tiles fracture, scattering their energy, disrupting the precise geometry of the superheated plasma, effectively neutering its penetrative power. This technological leap defined a new generation of Western armor, becoming the foundational DNA for the M1 Abrams and the Challenger series. The tank was reborn, no longer a purely kinetic entity, but a composite leviathan whose protection lay in complexity, not just density. However, in this eternal arms race, countermeasures breed countermeasures with alarming speed. If the composite shield was the answer to the shaped charge, the Soviet bloc quickly formulated the rejoinder, explosive reactive armor, ERA. ERA represents a fundamentally different and aggressively active defensive philosophy. Rather than passively absorbing the hit, ERA fights fire with fire. Panels of Contact 1, widely seen on Soviet tanks after the early 1980s, consisted of metal casings containing a sheet of explosive propellant. When struck by a heat warhead, the explosive detonates outward, forcing the metal plates to fly into the path of the incoming metallic jet. This dynamic interference shears and distorts the jet, significantly reducing penetration. Contact 1 offered a necessary, albeit limited, stopgap, primarily effective against single-charge heat rounds. The increasing sophistication of anti-tank weapons demanded a more robust reaction, leading directly to the deployment of heavy explosive reactive armor, HERA, exemplified by the formidable Contact 5.
Contact 5 introduced a revolutionary complexity. It was designed not only to defeat shaped charges, but also, crucially, to disrupt kinetic energy penetrators, the long, slender, fin-stabilized discarding sabot, rods fired from opposing tank guns.
Contact 5 achieved this by utilizing a much thicker, heavier outer plate, angled obliquely. The reactive detonation causes this heavy plate to shift violently, impacting the KE rod sideways, inducing massive bending stress and often fracturing the penetrator before it can reach the main armor package. This advancement blurred the lines between passive and reactive defense, creating a synergistic shield where every layer compensated for the weaknesses of the others.
The response from missile designers to the proliferation of ERA was swift and brutal. The development of the tandem warhead. Missiles like the Tau-2A and later generations of the Cornet introduced a leading precursor charge, a smaller-shaped charge designed specifically to prematurely detonate the ERA tile. Once the ERA was neutralized, the main, much larger follow-up charge, the killer blow, could strike the exposed underlying armor with devastating effect.
The battle for supremacy was now being waged in milliseconds, forcing the armored community to seek a quantum leap in defensive technology. This imperative birthed the era of non-explosive reactive armor, NERA, and non-energetic reactive armor, NX-ray, attempting to achieve the jet disruption benefits of E-ray without the logistical and crew safety hazards associated with high explosives.
Layers of rubber, ceramics, and metals are designed to bulge and move rapidly when struck, utilizing the impact's stored energy rather than a chemical reaction. However, the true zenith of modern tank protection lies in a technology that abandons the concept of merely hardening the skin, opting instead to neutralize the threat before it impacts. The Active Protection System, APS. APS fundamentally transforms the tank from a static defensive structure into a dynamic defensive ecosystem.
These systems operate in two distinct but often complementary modes: soft kill and hard kill. Soft kill systems, such as the Russian Shtora or the American flares, utilize sophisticated radar and infrared jammers to confuse the missile's guidance system, forcing it off target. They disrupt the weapon's brain. Hard kill systems, such as the Israeli Trophy or the Russian Arena, are the ultimate expression of the shield wall. These systems employ ultra-fast detection radars to track incoming threats, be they ATGMs or rocket-propelled grenades, from the moment they are fired. Once identified, the system calculates the intercept trajectory and launches a tightly focused counter-projectile or fragment charge toward the incoming threat. The Trophy system, deployed on the Merkava and now integrated onto the U.S. Abrams fleet, intercepts the projectile mere meters from the vehicle, destroying it or radically altering its trajectory, a maneuver requiring algorithmic precision executed in the span of a single breath.
This multi-layered defense, RHA reinforced by composite ceramics, overlaid by reactive tiles, and finally guarded by an instantaneous automated hard-kill interception system, has transformed the tank into a mobile fortress of unprecedented complexity. Today's MBT is the evolutionary culmination of this 50-year-long struggle, a machine that is impervious, reactive, and ultimately proactive. Yet, the dialectic continues. Next-generation ATGMs are designed to attack the tank's less protected roof, top attack, or utilize hypervelocity designs that challenge the reaction time of even the most sophisticated APS. The shield wall has held, but the relentless ingenuity of the spear ensures that the architects of the armored world can never truly rest, For every evolution in protection simply dictates the design parameters of the next, even deadlier missile.